Okay, so we got some stamp cubes. How many did we get?
6 oranges and a bunch of yellows.
And a bunch of yellows. Okay, but what was the problem?
We don't know how many yellows we need.
We don't know how many yellows we
we can
need.
always get more.
We can always get more if we need them. Okay, so how are we going to approach this problem?
Well, we could try picking. We could try picking out of this pile.
Okay.
But it might not be. I mean, I might not be correct because here, like, you get 2 yellows much more easily than you get 2 oranges.
Yeah, that's true.
Well, what else could we do? Well,
We could count the possible situations what you could do. So, you could pick 2 oranges.
Mm-hmm.
You could pick a yellow and an orange and a yellow.
are we counting these as different though?
That's a good question.
Because you are picking this one first.
Okay.
But
So, do you think those are different situations? Yellow first, orange second, orange first, yellow second?
yeah.
Okay. So we probably should count them as being different then.
So then we have 2 yellows.
Alright, so those are the different possibilities.
And we know picking an orange, then another orange is 1/3.
The probability of doing that is 1/3. Okay. So what would you like to
Well, maybe we could figure out the probability of picking 1 orange.
do? Okay.
Well, like if we just had 1 picking, if you just picked 1 every time.
Yeah, may as well. We gotta start somewhere.
Yeah, well, it's going to be out of n, because n is the number of sweets in the bag.
Okay. You wanna write some stuff down?
Yeah.
So the probability of picking 1 orange.
So 1 orange over n. There were 6 oranges, right?
Yep.
So it's 6 over n.
Okay.
And then 1 yellow is, well, 6 over n plus the yellows has to add up to n over n.
Okay.
So n minus 6 over n.
Though I think I see something here.
Oh yeah? What do you see?
I had an idea for the n. So picking an orange out of the bag, picking 2 oranges out of the bag, it's something over n. It's the probability.
Okay.
And that's something, well, if we figure out the thing on top, then we can figure out n by what's on the top, because we know the probability of picking 2 oranges is 1/3.
Ah, very good. That's very good thinking. We're going to get some fraction.
Yep.
And if we can set that, we know that fraction has to equal 1/3.
Yeah.
So your brother's written down the probability of picking an orange the first time is 6 over n. So that's really interesting.
Well, if we need to know the probability of picking a second orange.
Okay.
But we know that once we pick an orange, we don't put it back.
That's right. Why not?
Because we eat it.
Right.
So
Very good. So,
that means that the probability of picking another orange should be 5. That's the remaining oranges over n minus 1.
Because you took an orange out.
You took one out.
interesting. So we started with some number n, and we don't know what it is,
Yeah.
but we know how many oranges there were. So picking the first orange out was 6 over n, and then picking the orange out the second time was 5 over n minus 1.
So we have to add these together.
Or I think I think you have to multiply them together.
Ooh, good thinking here. Which one is it? Do you add or do you multiply?
Well, usually if you're using fractions here,
Do we add or multiply? Let's go to a simpler example with a coin. And sadly, I don't see a coin laying around anywhere.
I see one. Right here.
Okay. I knew our house would be messy enough that there would be a coin laying around somewhere. Okay, so we found a penny. If I flip it What's the probability that I get a head?
Well, if it's a fair coin,
Yeah.
1/2.
1/2. And if I flip it twice, what's the probability that I get 2 heads?
Well, 1/4.
Okay. So
And
what does that tell you? Should you add
And
the
1/4
probabilities?
is 1/2 times 1/2.
Aha. What would
So-
happen if I added the probabilities?
You would get 2 halves, which is 1.
1. So it would say the probability of getting 2 heads is 1.
So
So-
you get 2 heads every time.
Does that make sense?
No.
No.
That means the coin should have both. If that were true, the coin should have 2 heads on it.
Okay, very good. So what do you think we do with these two probabilities?
we
There's 6 over n and 5 over n minus
We
1.
multiply.
Okay, very good. Let's go to the next step here.
Okay.